here we are. Sorry about the lighting. It's the daytime. I just don't even know. I don't even know why the lighting is like this. It's horrible. It looks like gray or something. Oh well. Anyway, okay. So this is the fourth lesson for the week, or the fourth lesson that I've done for the week. You may not be on it on the fourth day, and that's okay. But the last 3 lessons, I did not do a video because those were things that I was assuming that you have already mastered. You might not, and that's okay if you haven't, but I was just assuming because I didn't know. So if you had trouble with any of those, I hope that you would have told me by now and I could help you on the rounding, the multiplication, and the division, because we can stop for a little while and practice on those if we need to. But if you're doing good and you're okay with that, we're just going to keep trucking. All right, so that brings us to section 3.5, and I wanted to do a little video today. I really could have, I guess, done a audio, but it's just easier sometimes to do this. So look in your book on page 76 on section 3.5 where it says properties. I wanted to go over this with you because these are really important. And this is probably something that you've never heard of. You might have, but I'm not real sure. All right, time to take a look at some properties or characteristics that hold true in every situation. As we look, keep in mind that properties are essentially naming consistencies that God holds together, so we'll be able to easily refer to them and use them to help us solve problems. That's all that a property is. It's just basically a truth of a consistency of God that we've named. All right, so the first one is the commutative property of addition and multiplication. Now, you may remember from reading in your multiplication is only repeated addition. So multiplication and addition, you might say that they are, I guess, brother and sister, you might say. Maybe they're cousins. And then you could say addition and subtraction are brothers and sisters because they're so opposite. And then, yeah, anyway, whatever. I'm just trying to think of some easy way to say it. All right, so addition and multiplication are what we call commutative. This, that is that we can rearrange their order without affecting the meaning. So there's you an example there. 1 plus 2 plus 3 is the same thing as 3 plus 2 plus 1. Doesn't matter what order you do it. Or if you want to try it with multiplication, 2 times 4 times 5 is the same thing as 5 times 4 times 2. You turn it around, backwards, front way, sideways, upside down, whatever, you're going to get the same answer. Either way, that's commutative. Subtraction and division, on the other hand, are not commutative because 5 minus 3 would not give us the same answer as 3 minus 5. Likewise, 6 divided by 3 doesn't give you the same answer as 3 divided by 6. The order in which we subtract and divide does matter, but not with multiplication and addition. You can test the different operations yourself to see if they're commutative by grabbing a handful of paper clips and going through the above problems or other problems. You'll find the order doesn't matter for addition and multiplication, but it does for subtraction and division. Thus, we can memorize 4 times 9 and know that it will always equal the same amount as 9 times 4. But 4 divided by 9 and 9 divided by 4 means something very different. We call this property of addition and multiplication the commutative property, which basically says we can change the order in addition and multiplication without changing the result. Okay? All right, look at the next page. Now this is a new property, the associative property of addition and multiplication. All right, not only does the order not matter in addition or multiplication, but the way we group or associate the numbers when adding or multiplying doesn't matter either. So if you have 1 plus 4 plus 2, it doesn't matter if you add the 1 and the 4 first, which gives 5, plus the 2 makes 7, or the 4 and the 2 first, which would give you 6, plus the 1 would give you 7. All the way you do it doesn't matter. The way that you associate the numbers in addition and multiplication does not matter. So there's an example right there. 1 plus 4. You remember, I'm not sure if you know this yet, but anytime you see an equation, a math equation that's got parentheses somewhere, you always want to do the parentheses first. That's what you will be taught when you learn that. If you already have learned that, you always do the parentheses first. So when we're looking at 1 plus 4 plus 2 and the 1 plus 4 is in parentheses, that just simply means do those first. So they did. 1 plus 4 is 5. And then bring down the plus 2, you get 7. The other problem is the same problem, but they grouped together the 4 and the 2. So you do that first, but you add it all up, get the same thing. Likewise, it doesn't matter 2 times 3 times 4. So look at the example down there. 2 times 3 times 4. It doesn't matter if you do 2 times 3 and then times 4, or 3 times 4 and then times 2. As you can see there on page 77, you get the same answer. We call this property of addition and multiplication the associative property, which basically says it doesn't matter how we group neighboring numbers in an addition or multiplication problem. It's important to note that subtraction and division are not associative. Consider 8 divided by 4 divided by 2. If you divide 8 by 4 first, you'd get 2. That answer, 2 divided by 2, then leaves us with 1. If, on the other hand, we divided 4 by 2 first, we'd have 2, and then 8 divided by 2 would leave us 4. And there's your example there, close to the bottom of page 77. That is why the associative property does not include division. It would not work. All right, notice that the answers are not the same. That's because division is not associative. The grouping in division matters. Unless there are parentheses changing the grouping, division is solved from left to right. So, subtraction, like division, is not associative. There's your problem. Go in there. Mama's recording your class for the girls. What?
I was going to ask you,
Yeah.
can I play?
If you go in there and play. Mama's got to get these girls some help, okay? Thank you. All right, subtraction, like division, is not associative. So here they're using the same numbers just with subtraction. So here they're saying 8 minus 4 minus 2, and they're going to do the 8 minus 4 first, which gives you 4. Bring down to 2, then your answer would be 2. All right, now they're going to bring it down and say 8 minus 4 minus 2, but do 4 minus 2 first. You get 8 minus 2 equals 6. Yeah, as with division, unless there are parentheses changing the grouping, you just simply have to start from the left and go to your right on subtraction. All right, next page. Why left to right instead of right to left? Solving left to right is the convention or the rule that we've adopted. By having a standardized order, everyone knows what is meant by 8 minus 4 minus 2. Since we're used to reading from left to right, then the order in that way makes a lot of sense. All right, here's one more property. This one's a pretty easy one. Well, they're both pretty easy, but they're all three, but this one's pretty easy. It's called the identity property of multiplication and division. Addition and multiplication also each have what we call an identity property. And what is an identity? Well, think about what the word identity means. It's referring to who someone is, right? In math, it's referring to two things that may seem different, but they're really the same thing. You see where it has a parentheses in your book there and it says IE? That means example. I have no idea why, but it does. They have the same identity. So let's take a look at what this means for addition and multiplication. The identity property of multiplication describes the fact that any number times 1 equals itself, and that 1 times any number equals that number. So in other words, 6 times 1 and 1 times 6 both equal 6. Now, 6 times 1 may seem different than 6, but they mean the same thing. So there's you an example right in the middle of page 78. So you have 6 sets of 1 equals 6. All right, look beside that. Here you have 1 set of 6, which equals 6. All right, this seems pretty obvious, but you'll be surprised at how often we'll use this property to help us solve problems, especially when we get up into fractions. Since multiplying by 1 doesn't change the value of a number, we call 1 the multiplicative identity. The identity property of addition describes the fact that adding 0 to any number doesn't change its value. So in other words, 0 plus 6 and 6 plus 0 both equal 6. Again, 0 plus 6 may seem different than 6, but they mean the same thing, and there's a picture of it for you there. 6 plus 0 equals 6, and then 0 plus 6 equals 6. Again, while this seems pretty obvious, understanding that adding 0 doesn't change a value is a pretty foundational concept in addition. Since adding 0 doesn't change the value of a number, we call this the additive identity. All right, now on page 79, we're going to summarize these properties. And on your worksheet today, I think it's the last problem on the back side of the page. It'll say to write all this down right here at the top of page 79 and to put that in your notebook. If you made a math notebook, yay. If you didn't, that's okay too. My daughter didn't make a math notebook, but you can have one if you want to. Actually be pretty cool if you did. My daughter I give her index cards, and she'll just write. She was having some trouble with the Roman numerals, so I had her write the Roman numerals on there, and she just keeps that card with her kind of stuck in her book so she can use that for notes. So you might get maybe an index card or something, and you'll want to write all those down. So these are summarizing these properties. So you have the commutative property of addition and multiplication. Order doesn't matter. Associative property of addition and multiplication. Grouping doesn't matter. Identity property of multiplication, multiplying by 1 doesn't change the value, and the identity property of addition, adding 0 doesn't change the value. Now I said there were 3 properties, and really the identity property is 1 in itself, but they're saying that there's 4 with multiplication and addition. All right, you can test these properties yourself with objects you have around the house, but they've already been tested, and I can tell you that they're pretty well true. So, all right, the next section says applying. That means using the commutative and associative properties. All right, let's say you needed to add a whole column of numbers together mentally. Because you know that addition and commutative is commutative and associative, you know that you can mentally rearrange and group the numbers together to add them up easier. For instance, if asked to add 5 plus 8 plus 2 plus 5, you could mentally rearrange or group them into what makes 10. You know 5 and 5 equals 10 and 8 and 2 equals 10, and then you add those up, you get 20. Okay, so you've used the associative property, probably, and the commutative property as well in your brain, just real quick like. On the other hand, if asked to solve 21 minus 7 minus 3, you would need to subtract each number in order from left to right. To get the correct answer, as subtraction is not commutative or associative, so you would have to say 21 minus 7 is 14, 14 minus 3 would be 11. Okay, so you'd have to do it from left to right in the order in which it is. Notice that if you instead subtracted 3 from 7 first, you'd get 4. Subtract 4 from 21, you'd have 17, and that's not the correct answer. When you do it from left to right, you'd get 11. The order in which we subtract matters. Since the agreed upon order is to solve from left to right, 11 would be the correct answer to that. All right, I hope I'm not moving too fast. This is pretty easy, all this stuff is. All right, the top of page 80, that gray box, anytime there's a gray box with that arrow pointing to it, that generally means this is important. Addition and multiplication are commutative, I always want to put an N in there, and associative within themselves, but not between each other. We'll explore in the next lesson what order to follow when dealing with multiple operations in the same problem, aka order of operations. That's tomorrow. All right, now we're going to apply the identity property. If multiplying any number by itself equals that number, and if division is the opposite of multiplication, it follows that if we divide any number, 0 excluded, as you can't divide by 0, we'll discuss that later, by 1, we'll end up with the number we started with. So 2 times 1 equals 2, and 2 divided by 1 equals 2. Think about it. If you divide 2 bags of candies by one person, that person gets both bags and probably a tummy ache. Likewise, if we divide any number by itself, 0 excluded, we'll end up with 1. So 2 times 1 is 2, and 2 divided by 2 is 1. Think about it. If you divide 2 bags of candies by 2 people, each person gets 1 bag and a little less tummy ache. Do you see how you can use one property, like the characteristic of how God governs an aspect of creation, to make additional observations about math? While these observations about division may not seem important right now, we'll use them extensively once we begin our exploration of fractions. And as for addition, while you may not hear the term identity property of addition you often use the knowledge that adding 0 doesn't change the value. For example, when you add 20 plus 5, you know your answer is 25. You just applied the identity property of addition because 0 plus 5 is 5. And you know that the 2 then would be brought down in the tens place. So you'll use that knowledge that 0 added to a number doesn't change even more as you get into upper level math, which If you go too much further, I won't be able to help you because I don't do very well in math. But these basic things are pretty easy for me. All right, so let's look at this worldview matters. Be on guard. A property is a description of one of the ordinances by which God sustains the universe. Unfortunately, however, properties are often presented as some sort of independent fact instead. Here's an example of a property presentation. A property describes the way something is. We can't change properties. We are stuck with properties because they are what they are. That's from Saxon's Algebra 2. And those are things that homeschoolers use as well. Notice this quote states the truth. We cannot change properties, yet they are what they are. Gives the impression that math properties sustain themselves, leaving us viewing a property as something independent from anything or anyone else. In contrast, a biblical worldview, far from being independent from God, a property is entirely dependent upon God. God's whole message is one of dependence. The Bible teaches us that we're dependent upon Him for our every breath. I was thinking about that this morning. I was standing outside just as the sun was coming up, and I was looking out in the backyard and out in the pasture, and I saw the animals out there, and I saw the sun peeping through, and I thought, oh my goodness, my very next breath is a gift from God. I'm not doing it myself. He's giving it to me. So, Satan, on the other hand, urges us that we can be independent from him. Back in the Garden of Eden, part of his temptation to Eve was to be as gods, knowing good and evil. Wherever you are, including in a math class, be on guard against subtle, independent thinking. So people always say, oh, it's good to be independent. Well, sometimes it depends on what you're talking about. Independent meaning when you grow up, you don't want to be making your mom buy your groceries for you when you have a job. That wouldn't be good. You'd want to be independent enough to buy your own groceries, but independent from God? No, never ever. All right, so as you review the associative and commutative properties of addition and multiplication and the identity properties of multiplication and addition, keep in mind that properties are truths about the ordinances God holds in place. All right, let's not forget that. All right, so you're going to do worksheet 3.5. So you'll want that in front of you. So I just kind of wanted to go over it with you right quick just to make sure you know what you're doing here. All right, so on number 1, it goes A through K. So on A, it says insert either equal or not equal. Remember the equal sign with the line through it means not equal in between these groups of numbers. So the first one is 8 plus 9 plus 2. And then you have 9 plus 8 plus 2. Now are those going to be equal or not equal? You should have said equal because they're addition, and being that it's all addition, it doesn't matter what order you put it in. Remember, that is your commutative property. So those are equal. And B, I gave you the answer to that one. What property describes the fact that the above groups of numbers were or were not equal? And that would be your commutative property. You can look back in your book and you can see the example on page 77 of the commutative property. 76. All right. On C, insert either equal or not equal in between these groups of numbers. And there's your groups of numbers. Equal or not equal? You should have said equal. And then D, what property describes that fact? Remember, those are the ones where they've associated two numbers together. So that's the associative property. All right, so I'm not going to do the rest of it with you. You can look back in your book if you need to. All right, now before you do that, look down at number 2. More property questions. All right, so these are just going to be basically questions from the things that we read. You might have to look back if you can't remember that. And look at the next page. On number 3 and 4, these are just review. And so as we go through this book, ever so often you're going to have sections going over things you've already done. It's just wanting to make sure that you can review, that you remember, you keep it fresh in your mind. So, and then on number 5, that's where it says to write down those properties in your notebook or whatever. You know, you could write it down or whatever, or make a copy of it if you can and cut it out, and you could fancy it up and put it on a piece of cute paper or something, put it on the refrigerator or wherever you do school, and have it right there, and just because you will be using these properties a lot. All right, so I'm going to give you, let's see, on this 3.5, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to make this 25 points on 3.5. If you have any trouble, if I went too fast, if I was not clear, let me know and I will be happy to help.